Entering Fido loves to into this chat interface triggers a specific statistical result, the word play. This demonstrates the final state of the product we are about to build. Over the next 6 minutes, you will construct this conversational AI from the ground up. The process involves training a model locally with PyTorch, saving the resulting file, and deploying it to a live public server. To follow these steps, you need the starter file package, a Google Colab notebook, and a free Hugging Face account. This architecture diagram outlines the Stochastic Parrot. This system functions as a statistical engine. It generates text by calculating the mathematical probability of the next word, based on patterns it identifies in a hard-coded story about a boy named Timmy and his dog Fido. Breaking down this pipeline replaces the perceived mystery of AI development with a repeatable engineering sequence. Our first task is creating the model artifact. Upload your starter notebook to Google Colab, open the Runtime menu, and select Run All. As the notebook runs lexical analysis, sentences break into individual words, each assigned a unique integer token. During Bayesian training, PyTorch feeds tokens into a neural network, adjusting connection weightings based on prediction accuracy. Confirm successful training by checking the loss curve in the notebook. A downward slope indicates the model is successfully reducing its prediction error. Once the cells finish, the notebook will prompt a download. Save the Fido Chatbot model.pt file to your machine. This file is the final output of local development. With 2,500 parameters of learned weightings, it is the AI artifact we move to the server. To make this accessible to others, log into Hugging Face, navigate to the Spaces page, and click Create New Space. Label the repository Fido Timmy Chatbot. In the configuration options, select Gradio as the Space SDK. This tool provides the web interface that users will interact with. Set the visibility of the space to public. This setting is required to use the platform's free hosting tier. After clicking Create, you will see a repository page with a tab labeled Files. Provisioning this cloud environment serves as the bridge between running a local code experiment and creating a product accessible to the public. Open the Files tab and upload the 3 required components: app.py, requirements.txt, and your .pt model file. Keep all 3 files side by side in the root directory, avoiding subfolders to ensure the script loads the weights. Also, ensure an exact match between the training text in your notebook and the text string inside app.chi to prevent tokenizer errors. Once you commit the files, Hugging Face automatically reads the requirements file to install PyTorch and Gradio before launching the server. Monitor the Build Status badge in the App tab. It will transition from a building state to a green badge that reads Running. This sequence of identifying updates, installing dependencies, and launching the app demonstrates moving a model from a development notebook directly to a production server. Now that the app is running, the chat interface is active at the bottom of the page. Test the deployment by entering Timmy went to. The model uses its learned PyTorch embeddings to predict the most likely continuation based on its training data. You have moved through the entire cycle of tokenization, local training, and cloud implementation to create a live application. You can now copy the public URL for this space. This link serves as a verifiable portfolio piece for your resume or GitHub. Successfully deploying this lab illustrates how raw data, PyTorch Tensors, and cloud hosting integrate to create a functional AI product.